talk about the history of the modern periodic table. So first is Dmitry Mendeleev. Remember we said we'd come back to him later? He was the first to organize the elements according to their properties. So he discovered that if you break the elements into columns and rows, you can have repeating properties and elements lined up with similar properties. So we call him the father of the periodic table. And he put his periodic tables in order of increasing mass, atomic mass, to see that their properties lined up. Next comes Henry Moseley. He reordered the periodic table in order of increasing atomic number. So, important here, Moseley was atomic number, Mendeleev was atomic mass. Now, whenever Moseley rearranged this to be in number instead of mass, it got rid of some of the problems that occurred with the Mendeleev periodic table. And Henry Moseley's periodic table is what we use today. The arrangement of the periodic table is by their atomic numbers so that the elements with similar properties fall into the same column. And remember that a column is up and down. So there are several different columns with similar properties, and just by seeing how close an element is to another element, you can tell a few things about that particular element. Periodic law refers to the physical and chemical properties of elements that tend to recur in a systematic way with increasing atomic number, meaning that if you go back here, you have alkali metals, alkaline earth metals, lots of transition metals, some metalloids, nonmetals, etc., and then they'll repeat every 8 or so numbers. So again, it just refers to physical and chemical properties that reoccur. All right, valence electrons are the electrons on the very outermost shell. So if you look down at this picture, there are two shells. Here's one shell, here's two shells. The outermost shell is called the valence shell, and the electrons on there are called the valence electrons. So this particular atom has one valence electron. Right, it's Ve negative. So those valence electrons are the electrons that are able to do bonding. So atoms can gain, lose, or share those electrons to form compounds. Atoms are most stable when they have an octet, which refers to 8 valence electrons. Now I'm just going to go ahead and say real quick that hydrogen and helium are exceptions. Because these ones only need 2 valence electrons to be stable. But we'll get to that later. So 8 valence electrons are stable except for hydrogen and helium. Alright, so this is how our periodic table is arranged. We've got metalloids mostly on this stair-step looking column, metalloids right here. And they break up our metals to the left and our nonmetals to the right. So on most periodic tables that you'll see, they will have a stair-step, and you can tell that metals are on the left side of the table, nonmetals are on the right side of the table. The only exception is right here, nonmetal, this is hydrogen. Alright, properties of these different things. Metals are excellent conductors of heat and electricity. That's why we use them in our wiring and in our pots and pans, whatnot. They're also shiny. They can be ductile, which means we can stretch them into thin wires, hence the reason for using them for wiring. They're also malleable, meaning we can hammer them into sheets. Remember both of these terms. They're going to be important. And a chemical property, all of these were physical up here. They were physical properties. A chemical property of metal is that it reacts with water to produce some sort of corrosion. So they're corroded by water. Properties of nonmetals. So nonmetals are poor conductors of heat and electricity, meaning they don't conduct very well. They're not malleable or ductile. They're brittle and break easily, whereas the metals were very easy to bend without breaking. They're dull, not shiny like the metals, and many of them exist as gases. So sulfur is an example of a nonmetal. Now, properties of metalloids. So if you look at this, in the name it says metal, but then it has this oid at the end, which means it's kind of like that. So it's kind of like a metal. Sorry for that poor handwriting. Alright, so metalloids are metal-like. They have some properties of metals and some of nonmetals. They're solids that can be shiny or dull. You see this silicon here is shiny, not always. They conduct heat and electricity better than nonmetals, but not quite as good as metals. See, they're kind of the in-between. These are, however, ductile and malleable. So those are the three major types of elements you'll find on the periodic table. Thanks for watching. You guys did great. Can't wait to see you again.